This motion picture is about the relationship between three meteorological phenomena: temperature, pressure, and wind. A condition that affects this relationship is the fact that the Earth's surface is unequally heated. You will see here how this results in pressure differences, which in turn cause winds. The large airtight chamber you see here is heated unequally, in much the same way the Earth's surface is. The floor of the chamber is warmed in the center with a heat lamp to simulate the conditions at the Earth's equator. The ends of the chamber are resting on blocks of dry ice. The blocks of ice represent the conditions of extreme cold found at the North and South poles. Smoke tracers are released in the chamber so that you can observe the movement of the air currents. Can you describe the directions in which the two air currents flow in the chamber? Air circulation flows counterclockwise at your left and clockwise at your right. This airflow is caused by unequal heating. Now observe the air movement at the center of the chamber. In which direction is this air moving? The air at the center, near the equator, rises toward the top. Why do you think it rises? The air rises upward because the heated air expands and becomes less dense than the surrounding air. What does this pattern of air movement indicate about the pressure at the equator? The pressure is lower near the surface. What is happening to the cold air at the ends of the chamber? Near the ends of the chamber, the cold air at the two poles is sinking. This action results from the greater density of the air caused by lower temperatures. What conclusion, therefore, can you make about air pressure near the poles? The pressure is greater near the poles. How does the air movement on the floor of the chamber differ from the movement at the top? The pattern of the airflow along the floor is exactly opposite to the airflow at the top. Air flows into the center near the floor and away from the center at the top. In this same way, air movement along the Earth's surface can be exactly opposite from the air movement in the upper atmosphere. We know that air flows toward areas of low pressure and away from areas of high pressure. What then do you think would be true about the pressure patterns at the bottom of the chamber? This shows that the pressure near the floor is also opposite the pressure at the top. In general, you can expect a trough of low pressure near the Earth's surface to encircle the globe along the equator. At each pole, you can expect a surface zone of high pressure. The map you now see on your screen shows world pressure and wind movement for the month of July. The areas of high pressure are shown in blue. Notice the arrows that indicate air movement away from the high pressure areas. Areas of low pressure are indicated in red. Arrows show air movement toward the low pressure areas. This map also shows that three basic pressure zones exist at the equator and at the poles. In the mid-latitudes, however, air zones of high and low pressure exist next to each other. What type of pressure is shown over Asia on this July map? On this map, a low-pressure center is located over Asia. What pressure center is located over the Pacific Ocean on this July map? An area of high pressure is located over the Pacific. Now, examine this world pressure and wind map for January. Describe the pressure over Asia now. In January, a high-pressure area is centered over Asia. Describe the pressure over the Pacific at this time. A low-pressure center is now shown over the Pacific Ocean. The two largest expanses of land and water, Asia and the Pacific Ocean, clearly illustrate that the relationship between the low and the high pressure areas in July is the opposite of the one that exists in January. Can you explain why this is true? This is true because in summer, the land area is warmer than the area of water. In winter, the water is warmer than the land area. The final demonstration shows why the temperature differences in land and water occur. A light is located here above the closed glass chamber. The light is equidistant from both the land and the water. What is true about the amount of radiation falling on the land as compared to that which falls on the water? Because the light is equidistant from land and water, equal amounts of radiation are falling on each. The thermometers, however, reveal that the temperature over the land is higher than the temperature over the water. What does this indicate? This indicates that the surface of the land must be heating up faster than the water surface. Can you explain why the land heats up faster? There are several reasons why this happens. The transparent nature of water enables the energy to penetrate to deeper layers. Water circulation also helps distribute the energy to deeper layers. And finally, it simply takes more energy to change the temperature of water than it does to change the temperature of a comparable amount of rock and soil. Now watch the movement of the smoke as it is once again released into the chamber. The unequal heating causes a circulation pattern that shows the air moving in a clockwise pattern, rising over the land surface and sinking above the water surface. Where then is the area of high pressure in the chamber? The high pressure area is above the water, and the low pressure area is over the land. This same condition occurs in a natural setting in the summer. How would the condition differ in the winter? The condition in winter is just the opposite. In winter, the high pressure area is over the land, and the low pressure area is over the water. This results from the fact that the land loses energy faster than the water and therefore reaches a temperature lower than the water. You have seen in this motion picture how the unequal heating of the Earth's surface brings about changes in temperature, pressure, and wind. It's an important part in understanding the many aspects of the weather around us.